Managing memory by hand is like untangling cables while juggling chainsaws. Rust says relax, let's conquer smart pointers and fearless concurrency. Smart pointers are just pointers with extra smarts. Ownership, cleanup, and sometimes shared access. As you can see here, we have box T. It's for heap allocation, it's compile time checked. We have RCT, which is shared ownership, its borrow rule is compile time checked. And we have RefCell T, which is interior mutability, and its borrow rule is at runtime. We can see an example of this with our enum list of cons and nil, and when we run our main, we can see let list equal cons, box new, cons 2. Box moves data to the heap, and it's great for recursive or large data structures. So we can always increase this list. It doesn't have a set size. Next is our RC example. As you can see, we import RC using standard RC, and RC lets multiple owners share one value. When the last drops, cleanup happens automatically. Finally, we're doing our RefCell example. As you can see, we have to import it using standard cell RefCell. And what RefCell does is it lets you mutate through an immutable reference. So borrow rules are checked at runtime instead of compile time. You can also combine them using RC plus RefCell, like right here. We have both shared ownership and interior mutability. It's a powerful pattern for graph or tree data. Now that we can share data safely, let's share it across threads. So how do we spawn them? We do use standard thread, and when we call the thread, we're setting a vector list, and we're just going to do thread spawn and the function that we want this to work on. So here you can see we're doing print line and move, and we can then collect them, and we can run the threads in handles where we do join and unwrap. Each closure moves ownership inside its thread. Rust prevents data races at compile time. It's beautiful. Next, let's talk about channels for communication. Channels pass ownership between threads safely, the M in Rust's message passing model. As you can see, we have an example here of our threads being spawned, and we're sending a message with our format throughout them. Next, let's talk about Arc plus Mutex for shared data. Here, we have a counter. We've set up a new arc for it with the mutex, and we've set up our handles for the vector. And as you can see here, when we do a arc clone of the counter and we push the thread to work, it's only going to increment one at a time. All right, Rust makes concurrency safe by default, and that's the fearless part. Now, you've just built a foundation for servers, simulators, and parallel engines safely. Yeah, thanks so much. Have a good one. Bye-bye.